Hi, my name's Tom Wasley and I'm the engineering manager here for the Additive Manufacturing team at the MTC. And I'm going to be showcasing one of our recent projects to design a digital tool that allows us to evaluate AM process data. The intention behind this tool was to allow a decision-making point regarding the quality of the part to be moved earlier in the manufacturing process, where conventionally we would make that decision post-inspection. What this data will allow us to do through processing in this tool is to make a decision about part quality immediately post-build. There were two parts to this project. First of them was the development of the tool architecture itself, including the removal of data, the automated removal of data from our additive manufacturing equipment, processing through our Granta MI database, which allows us to process huge amounts of data, both build data and in-process monitoring data simultaneously. And then finally the web interface, which essentially is what your engineer would use to interface and access the information regarding part quality. Our additive manufacturing team focused on running a campaign of builds through this project, which allowed us to identify correlations between in-process monitoring data and defect presence in those parts, very specifically porosity. And we identified some correlation between those two that allow us to feed that information into an AI tool, which can process that large population of data to eventually output a part quality statistic. So this project provides two beneficial outcomes. Firstly, it provides an increased level of product assurance. So every part that is manufactured, regardless of whether it is successful or fails, has an element of data associated with it which can be inspected and assessed to understand part quality. This assurance can support down the line with part qualification, for example. In addition, with further development, this platform will allow us to identify specific defect locations, better informing downstream inspection rather than specifically scrapping a part immediately. In terms of next steps, there's a lot of opportunities to build on the foundation we created this year. Firstly, we can incorporate new data sources. It might be, for example, new in-process monitoring data techniques. The second of that is data population. We can add to our data population in order to make a more informed decision. The third of those is materials. We can increase our breadth of materials, increase our materials database, and therefore make decisions on a wider range of materials. And finally, there's the opportunity for us to identify new defects or focus on different defects to porosity, which has been a real focus in year one. If anyone's looking to find out more about this digital decision-making tool for additive manufacturing, visit our website or get in touch.